So in the first video, I taught everyone what the mean is and then how to find the mean. And now I will be talking about the standard deviation. So the standard deviation is a statistical measurement that shows how spread out the numbers in a data set are from the average mean, mostly to see if the data is standard, expected, or unusual, unexpected. So finding the standard deviation allows you to spot any outliers that might affect your data and can be used to see what the data means. So a low standard deviation means that the data points are clustered closely around the average, the mean, which the mean would be right in the middle. And then you can see that for a low standard deviation, it's peaked up right here. So most of the data is around the mean. And a high standard deviation is how spread out the data is over the mean, over a wider range of data. So we have the mean here, and then we have a more balanced bell curve because they're not all centered around the mean. So something to realize for standard deviation is that it is only used when the distribution is normal, which means that it is a bell-shaped curve, which is right down here. And for the bell-shaped curve, we have points and they are distanced around the mean, which is measured by the standard deviation. So we have the mean, which is right here, and then from the one standard deviation to the left, and then one standard deviation to the right, 60%, 68% of all the data is right, is within one standard deviation. And then 95% is within two standard deviations of the mean, and then 99% is within three standard deviations of the mean right here. So an example that I have is male heights, which has a standard deviation of 3 inches. So the mean or the average height among most males is 5'10", and then we have heights going plus or minus 3. So we have 6'1", 6'4", and then 5'7", 5'4". So what this bell-shaped curve means is that 60% of males are 5'10", plus or minus 3 inches. So right here where this purple is, 95% of males are 5'10", plus or minus 6 inches, which is this red area. And then 99% of males are 5'10", plus or minus 9 inches. So over the course of this whole bell curve, we have heights ranging from 5'4" to 6'4", and 95% of males are in the range of 5'4" to 6'4". So that's just with the bell-shaped curve. If we want to find the standard deviation, which for males would be 3 inches, we can go over here with this formula. So this top formula with the S square is the variance formula, and if we take the square root of the variance, then we get the standard deviation. So I will break down the variance formula for you. So we have the sum x squared, which is the sum of all the x's squared. And then we have the sum of x's and then squared, which is just we add up all the normal data and then square at the end. And then the n is how many data points we have. And then we just square that, the results from that, and get the standard deviation. So we have an example right here. So I have a table example. So the first thing we're going to do is just square all the x's. So we already have all the data. So I will have my calculator on the side. All right, so 29 squared is 841. 15 squared, 225. 23 squared, 529, and this is 144, and then 169, and then 27 squared is 729, 19 squared is 361, and then 26 squared is 676. All right, and then I'll just break this off to make it easier to tell. And now we'll just add all of these up. So 29 plus 15 plus 23 plus 12 plus 13 plus 27 plus 19 plus 26. That is 164. And then we're going to add up all this x squared. So 841 plus 225 plus 529 plus 144 plus 169 plus 729 plus 361 plus 676, which is 3,674. All right, and using this formula, I'll just copy it over. All right. So we're going to take the sum of the x's squared. So this part of it, which is this side, because it is all the x squareds added up all together. So we're going to do 3,674 minus all the x's, which is 164, and then we're going to square that. And then we're going to divide this by the amount of data that we have, which is 1, 2, 3, 4, 5, 6, 7, 8, which is not counting the sum. So we're going to divide that by 8, and then we're going to divide, it should be n minus 1. Yes. n minus 1. Oops. Minus 1, minus 1. Forgot about that part. So instead of just n, it should be n minus 1. So instead of 8, it'll be 7. All right. So I'm going to do this part first because it'll be a little bit easier. So we're going to do 164 squared, and then we're going to divide that by 8. So we have 3,674 minus 3,362. And that is from 164 squared divided by 8. And now we're going to take that result and divide it by 7. So 3,674 minus 3,362 is 312. 312, and then we're going to divide that by 7. So divided by 7, which is the variance equals 44.57. Let's round it there. And then to find the standard deviation, we will just take the square root of that. So let's square root that. So 44.57, which equals 6.67 as the standard deviation. All right, and that's how you find the standard deviation.